Okay, so important workshop for the final exam. So, so everything is okay now. All right. So, question one: every face of the die is like every face of the die is like 1/6. Let me see. Recording. Uh, Question one says that, okay, fair means you have got six faces of the cube of a die. So fair means all of them are six. You have got six faces, and six faces means all of them should be equal. So let's assume that each of them is x, the probability of each x. So six of them together equal x plus x plus x. Six of them equals one. So it has to be 1/6. Not only six, but every other label. Regardless of the label, probability of each face is 1/6. Question two, um, event desired. I'm not sure about this question, what it wants to. So, okay. So let's look at this one. Probability of E2 condition E1 is equal to E2. So this means E2, if we even limit ourselves to the world E1, from the whole space is bigger. So, but if we limit ourselves to E1, then it will be the same as E2. So the limiting ourselves to the world E1 doesn't matter. It will be the same. Okay. So this means E2, the probability of E2 does not depend on the E1. Since probability of E2 E1 or given E1, then probability of E2 is equal to probability of E1, E2 over probability of E1. But it says that here E2. So this guy is equal probability of E2. But the original formula of this guy is equal to this one. From here, you can equalize these two equations. In these two statements, they will be equal. Therefore, probability of E bar in E1 intersection E2 will be equal to probability of E1 times probability of E2. Yeah. So this is, and to be honest, this is another equivalent definition of the two independent events from each other, independent from each other some textbooks, rather than doing this one first. Okay. So, all right. So this is written here as well from epochs contains so 3 red, 4 black. We take one of them by chance. Outside. This is now in outside. What is the second, like it's, and we analyze it and it comes back here. Or we take this one, we analyze it, and we put it back here. Now, second ball, we want to take it. What's the probability that first ball was set? Both of them are red. Well, you see that? First one, among these, okay, among these guys, which one is the red one? These three. Desired outcome divided by whole outcome. So this means 3 first one over 7. Now, both red means one action consisting of two consecutive or repeated after each other actions, means multiplication principle. Okay, so second one, since we took anything here, but we put it back again, the situation is the same. So 3 over 7. So this will be 9 over 14. Yeah, question 3. All right. So all right, question 4. Do you have a question about this? As I said, please pay attention because you won't be able to learn probability other than here. So last week by lecture, this week by lecture, and these 2 sessions with me, I mean, counted with workshop and this one. Next week, we will have another workshop, tutorial session. Pay to this university, so you will have 13 workshops. Since we were absent, I was absent in the week 1. So it's your right to ask for 13th session again. So we will have 14th, but I will keep it optional for you guys. Whoever has got a problem or consultant, yeah, you can see week 14 as well. It's very difficult course, of course. Question 4. Dairy has got 2 backup generators. Each of them works independently. The probability that a specific backup generates work when needed is 99%. What's the probability that neither works when needed? Yeah, so very simple information, but suddenly asking a difficult question. Okay, so probability of working first generator is 99%. All right, so neither of them working is, what's the meaning of neither works? A lot of things like W1, W2, not this, W2, W1, W2. Which one do you think? What's the grammar of using neither? What was your English score? English proficiency score? You get PT or IELTS? What was your score? 7.5. 7.5. What was your score? 0. What was yours? You want to know what it? Yeah. Maybe not. Ah, we know that. Neither means not. No. All right. Let me ask people's statistics. Private questions from people. Would you like to let us know? PT or IELTS? 16? IELTS? Oh, okay. Good. Okay. I will tell mine as well. Nian, what was your score in English proficiency? Huh? Did you take English proficiency exam to come here? Yeah. Well, which English exam did you take? Oh, the name. This means you care a lot. Does. Huh? Wow. Yours? Okay, 6.7. Mine was, huh? IELTS? All right. 6 or 6.5 or 7 or 5 or 4 or 3. Okay. Mine was 6. Me? Oh, okay. Okay. Oh, that's fine. I think I should have done it, but yeah, I did TOEFL exam. All right. So neither. Which one? No, this one or this one. Okay, I am writing their equivalent as this one. The Morgan's rule. No, English, not English exam. What's the equivalent of this? Negation of W1 and or like with this notation. Negation of W1 or negation of. So this is the probability. The difficulty of the probability is coming here. So at least even if it's not true in the daily conversation, but we need to be familiar with the conventional words in probability. By the way, negation W1 is same as W1 complementary, and so do for index 2. Right. So let's proceed firstly by this one. Probability of negation W1 probability of W1 union W2, different notation. This means this is equal to what? 1 minus probability of W1 union W2. Do you understand this one? Yeah? Did you understand? Probability of A complement is 1 minus probability of A. Goes to 1 minus, now principal in inclusion exclusion principle, W1 plus. All right, so now 1 minus. Probability of W1 is 99%. 99% minus. What's the probability of W1 and W2? Is 99% times 99%. Why? Why did I, for this one, why can I write this one as here? Huh? Yeah? What's your idea, Nian? Because they are independent. Yeah, so let me complete this one. Probability of, since they are independent, W1 intersection W2 is equal to W1 times W2. Do you understand this one? So I just used this one. Cut. Look at here. I used this one. 1 minus 99 over 100 minus 99 over 100 plus 99 power 2 100 power 2. From here, 1% minus 99 plus 99 power 2. Let's write 10,000. This will be minus 98. What's 99 times 99?
Times 29, right?
Yeah.
And 9,800.
This
800 or 80.
98,
0.
10,000. Okay, 9801 minus 98. What's that? Sorry. Can you do this one? 90 minus 98, I will add 0, 0. This will be 0, 0. Now it's not easy for me. So the 1, 10,000. Did you understand this part and this part? Just not common denominator. I just oversee, like I didn't see at first. The denominators should be the same. All right. So this is 1 over 10,000. What about this one? Probability of W1 complementary of, like, as we let's apply this one. So let's apply this one. Rather than this one, we will do this. If probability A intersection B is independent, possible to prove that probability of A complement same as A complement times B complement. So it will be probability of W1 complement times probability of W2 complement. Now here, look at here. W1 complement is 1 over 100 and W2 complement is 1 over 100. So this will be 1 over. So together it will be 1, 10, 10,000. So it's the same as this. Yeah, did you understand? Yeah. So, but you need to mention this theorem. It is possible to prove this. Is it possible to go with this one? Let's try with this one. So let's assume that we don't know the meaning of the neither. So possible wrong answer. So probability of negation W1 1 minus probability of W1 W2. So this will be equal to 1 minus probability of independent. W2. So this will be 1 minus 99 over 1,000, 100, 99 over 100. But I know that 99 power 2 is 98. So it will be 1 minus 9, 8, 0, 1, 10,000. So the answer will be 199 over 10,000. So this is not correct. It's possible you might write this one in your exam. So when I say W1, W2, both of them working, negation of the both of them are not working. So you should not interpret the meaning of the neither. Okay, so this will be the equivalent of this one is W1 complementary, W2 complementary. So the second one is, this means it says that the probability of that the first machine is not working or second machine is not working. This means one of them is may be working. Okay, you know, W1 complementary, W2 complementary. So anyway, you should say that neither means really none of them, yeah? Maybe let's say none of them means not working and not working. Let's stick with this one. And this one is easy. But if you interpret this one as none of them working, take both of them and complementary both. The same. So let's, for the forever in the life, neither means W1 complementary intersection W2 complementary. Neither is important than this question. This question finished, but you will expose the other equivalent questions in any place. Like in, not maybe final exam, but in the proper job applications, it will be this one. I'm pretty sure that you don't want to focus only programming. Yeah? You probably see yourself in more opportunities than only one. Question, do you have any question about this? Any question about this? All right, so question 5, a box contains 3 red and 4 black. Okay, so it's the same as here. All right, so 3 red, 4 black. Yeah, it's here. Removed random. So one of them removed. What's the probability of both threads? So this means first thread, second thread. So first thread, what's the first thread? Probability of the first thread. Throw a ball, red ball. Probability of the, if you throw a ball, yeah, 3/7. 3/7. Okay. One of the red gone. Okay. What's the probability of second one? Yeah. 2/6. So yeah. So yeah, the answer is this. Probability of 6. Question 6. What's the probability of random person is male and approver? Let's have a Venn diagram for this one. Oh no. Male and female. Can we have intersection? No. According to this question, no. So now let's have approver, some from male and some from female. How many female? Female, male, approver. Right. So let's do this. Male, approve. Not approve. Uh, male, uh, yeah. So male and approver is 62. Male and not approve is 27. Female and approver 45. Not approve 53. Random person is a male and approve. So this guy and male. So this means approve and male. This is the question. So the answer is 62 over everything. 62 plus. Do you understand? Is there any question about this? No, it says that given that person, Okay, when you see the word given, in given means conditional probability. You should remember conditional probability. It's never ever possible to see never given and you think something else. All right. So it might be interesting, but probability context books. So given. So if you translate these books in another language, you will see the same thing. So the given literally translated, but it means it's still again conditional probability. So probability of given that person approves. Okay. So I limit myself to the, so this means now I am only in the yellow part. Approve. What's that? What's the problem if it is female? Well, I know I limited myself to the yellow. Okay. So the answer is female. 45 divided by 45 plus 62. Do you understand? So this means marginal 62, 45, 107, 80. This one 62, 27, 69, 60, 70, 89. 553 is 98. All right. Now another question. Probability that suppose we choose someone and he is male. Okay. What's the probability that he said no? 27 over what's the total? Which total? What's which total? No, I said
Or is it titled?
62 plus 27. Yeah. Yeah, that total. What's the probability that the person is male and he said no? Excellent. 187. Given that a person says no, what's the probability that person may? No, 8. What's this? Brothers and sisters. What's the answer of this one? No, it's not male and no. It's male and condition no. What? 27. The probability cannot be more than 1. Should I write? Thus. Thus. What's the answer? What's the answer? Huh? Huh? This line. Male condition no. Oh, total of male. Oh, disapprovers. Disapprovers 80. Do we have such word? Disapprovers.
Yeah.
Unapprover, disapprover, non-approver. What's the probability of mm, probability of and provided that it was a she. Okay, this. So we can create condition of like 4 and intersection 4. So 4 plus 4 is we can create 8. What's that? What's the answer of this one? From yes, even female. What should I write? So approvers are females are 98 of them. How many of them are approving? 35 of them. Less than 50%. Is that so? You can see these questions 3 and 5. They are replacing and without replacing. You will see a lot in a lot of places. You will see a lot of places question 6 type questions. Question 7. It says that probability of when the machine is working is 90%. Working. It tells me that when it's not working, what's the probability of when it's not working? Machine 10. So do you remember this question for sure? So an perfect program or machine works in 90% of the times. When it's when it is working, it returns always the answer. When it's not working, the machine or the program does not work. It's with 20% probability, it returns the answer. Suppose that the program returns the answer. The condition returns the answer. Okay. The question program suppose that return the answer. Right? So what is the probability that machine works? W. When it works, return the answer. Probability that it returns the answer when it works is 100%. Probability that return the answer when it's not working is just 20%. I'm not sure, it's just by chance. So the question is asking this one. If you write this one, you have done this much, you have done 50% of the work. Okay. After this, let's stick on the definition of the conditional probability, working intersection, return answer. Probability of return answer. Do you understand? We know that probability of A condition B. Do you remember the formula? Okay. So if I times both of the sides by probability of B, so this will go to here. You understand? So this will be probability of B times probability of A condition B. The other guy was here. He's just participating optionally in this course. It's not obligation for him. That's why I don't need to take his attendance. It's just telling this to remove any misunderstanding. A union B. Did you understand? Now, what about this one? Probability of B condition A, probability of B intersection A, probability of divided by A. If I times again both sides by probability A, it will be so probability of B intersection with A, same as probability of A intersection with A. So you can write like probability of A intersection with B sometimes B condition B, or sometimes A condition B. So it's okay, yeah? Look at here. So W condition A, return answer. It depends what you have and what you don't have in your problem. So let's go here. Equals probability of this guy will be written as this. Probability of return. So I am seeing here. Okay, I am seeing here. And I will write this intersection as because of this first one. All right. Condition works times probability of works. Do you understand? I wrote like this one. Can I write W intersection the other way around to write it probability of W condition return answer? No. Probability of return answer you can write, but it won't help because you are after for this one. You don't know this. If you write W condition return answer, you don't know the amount of that to substitute here. Okay? Do you understand? Please, 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 I implore you, if you don't know, if you don't understand, please let me know. Probability of return answer is like probability of return answer intersection the machine working plus return answer the machine is not working equals now this guy here is same as this one. So I will write this one like this one. So let's copy this one to the numerator. Again here. Plus here. Says that W is complement. So I will write complement. Did you understand? So now the rest is not important because it's just substitution. Return the answer is just always 1. Return the answer when it's not working 20%. So this one, one times probability that machine working is 90%. Now this part, I'm writing this part is the same as the first one. 1 times 90% plus probability that return the answer but machine is not working. So we can look at here and we see that it's like it's what 20%. We will complete this one here. 20% times the probability that the machine is not working is just 10%. If we it will be 90 over 92. Okay, do you understand? Any question about this? Okay. So it says that we have got three identical red envelopes. And black envelope. Gold. In two of them, there are two gold. Gold coin. And one of the black envelope is called has got gold coin. So now let's apply this formula here. A1, A2, probability of B is the gold equal to probability of A1 times probability of B condition plus probability of A2 probability of B condition A2. So equal, what's the probability of A1 getting envelope, red envelope? 3 out of all of the envelopes means 3 over 7. times probability of gold, given that we have got, so we got the red envelope, okay, red envelope. What's the probability of getting gold? 2/3. Similarly, probability of A2 getting black is 4 blacks out of 7 times probability of gold from black. That's the answer. That's enough. You don't need to simplify these things. If it is multiple choice questions, yes, you do need, but in written answer question, you don't. Question 9 says that head 1/3, tail 2/3. So it says that x, what's x? X, every time probability of x, p, probability density function, x is variable. The definition of x will be varied, might be different. In this one, random variable x is a function from whole scenario to a real number, which is real number. So for example, x is here is 2, 3, 4, 5 until 12. Each of them, not each of them, sorry, 136. So summation of how to get this one, you need to refer to the sample, the space of the whole scenario, space of the two, when you roll 2 dice. For example, for this one, 1, 2, and 2, 1. So 2 cases, 2 out of 36. Here, x is number of the toss that you will take, you will roll it, you will flip it, the coin, and you will get first tail. Once you get the first tail, you will stop. So the scenarios will be are liking first tail. So it's equal 1. X equal to head tail. H H T H H H H H T. All right, like this one. What's this scenario of each of them? For this one is 1/3 times 1/3 times 1/3 head times tail 2/3. This one is 1/3 times 1/3 times 2/3. This one is easier, and this one is much easier. Therefore, the probability of x, when it's x is just in natural numbers, is 1/3 power k minus 1 times 2/3 . Yeah. Do you understand? Okay. So I am not sure how was the solution of this one. The solution is not well written. Okay. So if you look up these things on the internet, you will see these words. T, H, T, H, 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 T, H, 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 T. Okay. So if you toss the coin to be head, 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 so you will stop the game when you get T. So be k minus 1 time. So the case time will be high. So the probability of this one is question 10 says that the expected this one. It says that the tail is and row. All right. So expected value. So you 3 times you toss a coin the 3 times. So first of all, this is we will use this one. Expectation of how many times? 3 times toss. Expectation of tail. Tail. X belongs to means just 3 times. Probability of X equal tail. So here says that question 9 doesn't mean that this P is not this P. It might be different. It says that probability of tail or head. It doesn't say probability of the K equal 1, K probability of related to this question. Okay? Probability of getting tail and head and expectation of how many tails and how many tails. It doesn't talk about this. So from here, A probability of tail plus tail probability of tail. Tail probability of tail. Tail, what's the probability of tail? So since all of them is the same, it will be 3 times probability of tail. From here, 3 tail probability of tail. What's the probability of tail? Yeah. So 3 tail, 2/3. So it will be times 2 tails. 2 tails. So in some books, you can see this number. Expectation of when you toss a coin or die, roll a die. So expectation of something is equal to n times probability of that. We can see this formula. What about x in 3 times head? Expectation of number of head. So expectation is also average. 3 times head, probability of head. Probability of head. So 3 times head, probability of head is 1/3, so it will be just 1 head. So if you toss the coin 3 times, because the probability of head is 1/3, in 3 times, averagely you will get 1. Every 3 of them may averagely, not on a portion.
Is this
No. Fair means what?
half, right?
Oh.
Yeah.
In the interview of the last year, I got this question. I was doing a nice job in Sydney. Salary was like 300K. 300,000. You want me to repeat?
Let's
300.
suppose, let's suppose she's eating 3.
Yeah, 300. But But 99% of the applicants they got failed. They get failed. 99%. Reporting of rules. 1%. I think the 1% gets interviewed. After interview, many people will receive ranking. So I answered these probability questions. It was a finance company. SIG, Susquehanna International Group. Okay. So every year you can apply just one. It's not like, okay, I didn't get success, so I will do next time. It's not like that. Every year you can apply this one. I asked the questions. I did one time in 2023. So after 1 year, again I did another 2024. So I was familiar with the questions, with the type of the questions. It's just not one set meets of sets they happen, but they do like each other. It's like second chance after meets messages. Some people they were asking, like in my workshop, some people are asking me that, is there any workshop in week 13? I said, yes. What will we do? Second chance of meetings. I was like, second chance of meetings. What? They were like, what? But you should, I'm like, I should be confident that you have a look at the canvas messages, emails, okay? Next week, there is a second chance of mid semester.
How do they not know about this?
How? Because they just haphazardly come to the university.
Still cannot get this organized, you know.
And actually, you pay this university. So, in SIG, the 300K, it was so the in the interview said like, what do you do? What did you do? What was your PhD about? What's your favorite working things? And you say, okay, well, it is a finance company and they are doing trade. So they need some special. As, so then she asked me that, okay, so assume that there is a coin and it's a pair. What is the probability that after you do like infinitely you post this and you take this when you get HTH, you will stop reading. What's the probability? Head. What? Say that. And after the I saw that I went up to bed, up to a way, but I saw that it's not possible. So I got rejection. Then in the interview again, I saw that it's just if I even if I could answer the question, they would say they would not they would say that okay, you receive rejection. You know, uh it's hard. So these types of companies, the written answer, then exam with the Zoom, then exam in interview in person. You know, it's like that. All right. So this is this question. So I'm